D-Plant Horticulture is Ireland's leading polytunnel manufacturer. Our polytunnels are designed by professional horticulturalists and manufactured to the highest standards by our own engineers. Our complete range of polytunnels are suitable for the most extreme conditions. They are sturdy and strong and also spacious and comfortable to work within. The 2.4 metre or 8 foot wide allotment tunnel is suitable for town garden allotments or where space is restricted. Our small or large hobby tunnels are 3.7 metre 12 foot or 4.6 metre 15 foot wide. These tunnels are most popular with domestic gardeners. The large garden or commercial tunnel, which is 5.5 metre 18 foot wide, is ideal for the real enthusiast and small commercial grower. The 6.4 metre 21 foot wide commercial tunnel is large and spacious, and with a 3 metre 11 foot centre height, it gives ideal growing conditions for a wide range of crops. All tunnels range in length from 2.4 metre through to 22 metres long. For more information and prices, check out our website at dplant.ie. Your tunnel will be delivered by our courier direct to your door or allotment, complete with all the parts you need to construct your D-Plant polytunnel. The following tools are required to construct your tunnel: a shovel and a spade, a drill, hammer and spanner. A folding square will help to ensure square corners when laying out your foundation. A Stanley knife, builder's twine. Additional to the required tools, we recommend these tools for construction of a medium or large size tunnel: hard hats, a pair of folding ladders, an impact driver drill with long reach 13mm and 17mm heads, a large spirit level, a long tape measure, 2 handheld clamps. This DVD is a guide to the construction and covering of a garden polytunnel. It should help you get the longest possible life from your tunnel. While this demonstration is of a medium-sized tunnel, the same principle is used for all tunnels, even the largest, using this method. The main components of your kit include foundation tubes and protective cap, ridge pipe, hoops, U-bolts and clamps, diagonal corner braces with Q clips, door frames with P clips, anti-hotspot tape, polythene plastic covering, battens to secure the polythene cover. Preparation of your chosen site is essential. Generally, you should have a level, even surface to work with and a location with as much wind protection as possible. It is a good idea to clear your site of stones, grass and weeds and ensure your soil is in a healthy growing condition. You can achieve this in many ways, but the addition of farmyard manure or compost will work very well. In this video example, we will be demonstrating 2 construction methods: the typical trench type, where a simple trench is dug to secure the polythene to the ground, and the base rail method, where a wooden rail is secured to the foundation poles and your plastic cover is then attached to this rail. This method, although more expensive in terms of materials, allows more options, such as constructing the tunnel on a paved surface, or will allow you to attach guttering to your tunnel to harvest rainwater. The foundation layout can be achieved by using pegs and strings to mark out your overall width and length, and also to square your corners. You should ensure that your overall length and width does not exceed the size of your purchased tunnel. You can also ensure your layout is square by measuring the diagonal length on both sides, and these measurements will be the same if your layout is square. Assemble the ridge pipe and use it as a spacer for the foundation tubes. Carefully check the measurements for your overall length. Ensure the foundation tube is the correct way around. There will be a small pinch near the top so that the hoop does not slide all the way down into the foundation tube. Use the protective cap provided in your kit. Drive the corner foundation tubes to their described length. Depending on the size of your tunnel and your soil conditions, you can use concrete to secure your foundation tubes. The tubes are crimped near the middle, and this is where concrete can take hold of the tube. Please read your instruction booklet for further details. Drive or set the intermediate foundation tubes down to the level of the corner foundation tubes. This can be achieved using a string or straight edge as shown here. You can also ensure the tubes are vertical with a level. If you have used concrete, you should allow the tubes to set overnight. The hoops come in two sections and are fitted to each other and then slotted down into the foundation tubes. Note that the top end of the hoop will have a burred machined edge to it. This end will be at the top of your tunnel, and the other end will be slotted into the foundation tubes. Assemble the U-bolts as shown here before fitting the ridge pole. Place each bolt assembly into position up on each hoop. Starting at one end, secure the first pole in place with a U-bolt as shown here. Continue to place all the other ridge poles into position, but do not secure them into place. Secure the final ridge pole. With assistance, look down the entire length of the tunnel to ensure you have a straight ridge pipe. Work your way down along, adjusting as necessary and securing each U-bolt as you go. The ridge pipe doesn't necessarily need to be under each joint of the hoops. The ridge pipe should be straight, but the hoop should be positioned so that the U-bolt is secured to both sides of each ridge pole, as shown here, ensuring a firm grip on both ridge poles. Tighten the U-bolts and clamps to firmly secure the structure before moving on to the next stage. Fit Q-clips to the first, second last and last hoops. Fit both sides of the corner bracing poles together. With the bolts pointing inwards, loosely fasten the corner bracing, ensuring that the flat end of the brace bar is to the inside of the Q-clips, not in between the clip. This will ensure that the clip is tight on the hoop just above the foundation tube. Tighten the lower end of the brace bar first so that the top end can be moved up or down to allow you to square the gable end of your tunnel. Fitting all 4 corner braces makes your structure rigid and strong and helps your polytunnel stand up to adverse weather conditions. You can use Tek screws to securely join both parts of the corner bracing poles. This will keep everything in position until you cover with polythene. Secure all Q-clips with Tek screws provided. With assistance, hold up the door crossbeam to the polytunnel and check the level and see where the ends meet the hoop. If the corner bracing is going to be in the way, you will need to readjust the corner bracing as shown here. Fit the door frames using the P-clips provided, flat side facing out. First, fit the crossbeam secured with 1 screw on each end, leaving these screws loose until the crossbeam is levelled. Once the crossbeam has been levelled, the screws can be tightened and a second screw can be inserted into each P-clip to secure. Repeat the process for the other end of the tunnel. To fit the doorposts, using a plumb line or level, mark the ground for the doorposts directly below the joints in the crossbeam. If there are no joints on the provided timber, you will need to mark out the middle of the crossbeam and then mark for the width of your door or double doors depending on the size of tunnel purchased. In this example, a 1 metre door is marked and doorposts are positioned with a level to mark the ground. Dig the holes just deep enough for the doorposts and crossbeam joints to be assembled. After fixing the joints together with screws or metal brackets, the doorposts are plumbed and the holes are backfilled to secure the doorposts in place. When your first doorway is complete, repeat the process at the opposite end of the tunnel to install your second doorway. You may use concrete around doorposts if you wish. Dig a trench down both sides of your tunnel and into the door frames. The trench should be 16 to 18 inches deep and approximately 10 inches wide. In this example, we are demonstrating both trench and rail methods. For the rail method, it is recommended to purchase lengths of 2x4 pressure-treated timber from a local supplier, If ordered from D-Plant, you will receive nuts, bolts and required rail brackets, both corner and internal brackets. Cut your rail to the required length, ensuring that it extends beyond the corner foundation tubes by the width of the rail to allow you to connect the front and rear rail to the side rail as shown here. Raise the rail up using offcuts of your 2x4 timber. This helps in applying tension to your polythene later on. Drill the rail and insert the bolts, brackets and nuts to secure the rail to the foundation tubes. All D-Plant horticultural tunnels are supplied with anti-hotspot tape as standard. This tape is applied to the outer surface of the hoops and prevents abrasion to the polythene and so extending the life of your polythene cover. Roll out the tape and rub over it with your hand to help stick it to the hoops. You can also apply some tape to the ends of the ridge poles. To cover your polytunnel, first pull the sheet of polythene over the structure and allow the same amount of excess on both sides. For larger tunnels, 2 people are needed to do this. You can lift the roll up onto the ridge pole and hoop, then roll out the plastic along the top ridge poles. For larger tunnels, roll out the polythene along the ground and then lift up and along the tunnel. Center your polythene and give an even amount of polythene on the front and rear of your tunnel. For larger tunnels, you secure the polythene by fixing the first middle batten on each end at the top and middle of each doorway before you drop down the polythene on both sides. For all tunnels, you can quickly pull the polythene down to the trench and fill in a few shovels of soil to secure it. A few inches below the top section of the door frame, cut a small section in the polythene, the width of your first batten, and roll the batten onto the polythene as shown here. Repeat this at the other end, securing your polythene into position. All D-Plant polytunnels come with anti-drip polythene. To tension the tunnel covering, the polythene is fixed to the door frames using timber battens, starting in the centre over the door as shown here. With the first batten fixed to the door frame, this process is repeated at the opposite end of the tunnel. This ensures a lengthways tension on the polythene. Note here how the rolled up polythene is cut at each end of the batten after it is fixed to the door frame. When you reach the corner of the door frame, pull the polythene diagonally to remove any slack. Make a diagonal cut from the corner out, as seen here, to divide the polythene between the top batten and the side batten. As you roll the polythene around the batten, allow folds in the polythene. This is to absorb the excess polythene caused by the curved structure and gives a neat finish. This procedure can be clearly seen here. You should allow folds on any battens tensioning polythene from the curved parts of the structure. Continue to fix the polythene over the door frames, working from end to end to gain as much tension lengthways as possible. Note here the way we remove the middle batten to retighten the polythene. After getting good tension on the outer battens, middle battens may become loose and need adjusting. In this case here, we remove the screws to retighten the battens. Continue to tension the polythene, fixing it across the door frames and working from end to end until you have completed this lengthways tensioning. Fixing the polythene all along the door frame must be completed before moving on. Check all battens for tension and retighten if necessary before moving on to the next stage. If using nails instead of screws, do not drive them completely home. This will allow you for batten adjustment if required. Backfill in the trenches will tension the polythene along the sides of the polytunnel. First, take a section in the centre of the trench on one side as seen here. Backfill the trench and walk it down firmly. Repeat this process at the opposite side of the tunnel. and fill in the centre section of the trench. This fixes the polythene and prevents it from being pulled off centre. Continue to backfill the trench out to the corner, pulling the polythene down tight and walk it in firmly. Both side trenches can be completed at this point, but not the gable end trenches. Note here how if you stand on the loose end of the polythene, it keeps it off the bottom of the trench, allowing the soil to tension the polythene. Firm the soil in well by walking it down to keep the tension on the polythene. Split the polythene diagonally at the corners of the trench, below ground level as seen here. This allows the polythene to be pulled neatly around the corners and fixed to the doorposts. Repeat this process on all corners. To attach your polythene to your rail, you will first need to trim off the excess polythene. Leave approximately 75 centimeters of polythene past your 2x4 rail, leaving enough to fold a batten onto the plastic to secure the polythene to the rail. Cut with a knife. Starting from the middle of your tunnel, using battens of approximately 1 meter in length, fold the batten onto the polythene and secure it tightly and evenly to the rail. Screw into place. Continue this process along the length of the tunnel to both ends. When completed, you can enter the tunnel and remove the offcuts, keeping the rail raised. Using a length of 2x4 or similar, hammer down the rail as shown here. Work your way along the rail and tighten the bolts fully. Secure the front and end rails to the door frames with the provided bracket. Tension the polythene to the doorposts. Pull the polythene in from the side as seen here, allowing folds to gather in the polythene before rolling onto the batten. Ensure the polythene is tight before fixing the batten to the doorposts using nails or screws. Cut the polythene below the top batten on the doorpost to release it in order to fix the next batten. Here you can clearly see where we fit the next batten and then readjust it to get the best possible tension on the polythene. Repeat this process on the next batten down along the doorpost. Check the tension of the polythene and retighten any batten if needed before moving along. Continue by repeating the same process on all remaining doorposts. Ensure you pleat and fold the plastic neatly before wrapping it to the battens as shown. For the rail method, secure the remaining loose polythene to the rails with battens at the gable ends of the tunnel. For your trench, trim off the polythene at ground level as shown here. Backfill the remainder of the trench up to the original ground level. The gable end trenches can also be filled in at this stage. Tidy and level off the ground and firm in the soil around your polytunnel. Finally, check all the battens once again for tension and remove and retighten where necessary. While this guide to the construction and covering of a polytunnel may not be for the same size or model that you have, the principle of covering is exactly the same. Thank you, and remember that D-Plant Horticulture gives you the power to grow.